line of code and then both try to push that to GitHub, GitHub will let you know. You can't do that, pick which one's correct. Like, and it's just got a lot of really cool features. It was designed primarily for working collaboratively over code, but you can version control any kind of document you get. It doesn't have to be code. It can be any kind of text file, even like Word files, although it becomes a little tricky, but I use it for Word files.
Right. And to clarify, I guess the difference between Git and GitHub, unless you did that while I wasn't listening, but Git is what we'll be using for version control. And it's a bit hard to describe, but it's kind of the tool that we'll be working with in the command line here. Same as our Bash lesson from 2 weeks ago. But GitHub is just it's just a website that allows you to upload folders that are Git controlled and just have them visible for the world to see, and facilitates the collaborative aspect of Git. So for the first half, we'll be working entirely in the command line. We'll make a repo or folder that's Git controlled, shortened to repo often. We'll do a couple things in it, get familiar with basic Git commands, then put that onto GitHub and then see kind of what it looks like on that side of things. We won't be going to collaboration too much today because that would make the lesson way too long. But that of the future lessons we've mentioned, although we haven't scheduled that one, it's definitely one that we'd love to run. For context, James and I made the website and all these lessons through Git together. So it's a super useful skill to have. So to start off, just get whatever sort of bash terminal you have. If you're on Windows, I guess that'll be Git bash. And now you know what the Git half of that means. If you're on a Mac, it should be terminal. And people on Macs, does anyone not have Xcode installed?
I don't know.
Okay. What happens if you type in, well, everyone try this actually, git -- version. Git space -- version. Uh-oh. Are you on Mavericks or greater, like your OS? So you're gonna have to install Xcode from the Mac App Store, but it's pretty big. Like
I tried to, but it won't. It's not like I need a more recent version of it.
Right. Well, in that case, I guess you could still follow along from what I'm doing up here, and the material's still up there, but you might not be able to code along. Yeah, it's a bit of an annoyance if you're a Mac user because Xcode is huge, but you kind of need it to have Git working on your computer. If it comes up with a Git version, that means you have Git installed, so you're good to go. Okay. Cool. Yeah. So like James said, Git is a system for version controlling files, any kinds of files, code, manuscripts, data even. And what's it called? It basically is a means of documenting all the changes you make to a given file, such that each file of interest has a whole rich history of changes that you've made that you can go back to, explore, maybe recover things from as need be. So if we're going to be documenting our changes, the first thing you have to do is actually tell Git who we are. So in order to do that, we'll do a couple quick configuration commands. You'll only have to do these once, so pretty much in this lesson. And then from here on out, you'll never have to run these again, unless you, I don't know, change your name or something. So in order to set that, we'll be using a command known as git config. And I'm just going to mention right now, every command we'll be using in Git will start with the word Git. So prepare to type that word a lot. It's usually Git, then followed by whatever other command within Git that we want to do. So git config -- global, spaces between all of these. We're first going to set our name. So this would be user.name. Is this big enough for everyone to see, by the way? Okay.
Yeah, actually.
Can I just what? Sure. Like, okay. I'm just going to cancel this. No, that's actually should be fine. All right. So user.name, and then within quotes, I'm using double quotes here, but I think single or double works. Just write out your name. And this will be important because this is a name that'll be associated with each of the changes that you make. So once you've done that, there should be no input, but kind of in the back, Git now knows who you are, pretty much. After that, we also have to tell Git what our email is. So git config -- global user.email, and then in quotes once again, whatever your email might be. So I'm going to use my uToronto email. Feel free to use your Hotmail email from when you were 13. Whatever you'll be using with Git. And then the last thing we'll set up, and you don't particularly have to do this if you don't want to. So in parts of certain aspects of Git, it'll put us into a text editor in the terminal. And we saw a few of these last time. We looked at Vim or VI, we looked at Nano, and by default, Git uses Vim. And a lot of people don't particularly like Vim, which I don't understand, but to each their own. So if you'd like to change your text editor, those who are fine with Vim, you don't have to run this, but this would be git config, again, -- global, then core.editor. And then after that, you could write Nano, you could write Emacs, whatever you prefer. This is more a preference thing, but just something I want to point out because some people just really do not like Vim, and that's their prerogative. You could even other text editors such as Notepad++ or Sublime Text, as long as you have some sort of alias for that in the path, which if you'd like to do, we could look at after the lesson. You could define that as the core editor for for Git as well. So once you've done that, that's pretty much all the dull configuration stuff out of the way, and you never have to do that again. So now we can get right to actually creating a folder and then version controlling some files. So does anyone maybe remember what the bash command to make a directory was? I sort of said it, but yeah. Exactly. So mkdir will make a directory. This will just be like any other directory we've made so far. Make sure you're in a place where you would want this directory to be made. I'm currently on my desktop. If you forget where you are, I'm going to cancel out of this. You can press pwd, remind yourself where you are, and then use the cd command. Sorry, let me move this up. And then use the cd command to navigate to a different folder if you'd like. So on my desktop, I'm going to make this directory, and I'm going to call it About Me. And you should do the same, because we're going to do what everyone's favorite thing is, talking about ourselves. Once you've done that, we'll use the cd command. So once again, change directory to enter this directory we've just made. And if you type in ls here, you'll see that there's nothing in here, as we'd expect. Right? Now, in order to turn this perfectly ordinary directory into something that Git is now keeping its eye on and tracking, we have to initialize this as a Git repository. So that's a bunch of jargon right there. But a Git repository is essentially a folder that Git is tracking changes within. So in order to do that, we would type in git init, init being short for initialize. And it'll say initialize empty Git repository in, and then kind of the path to what we have over here. So what this actually does, although if we type in ls, nothing has actually happened to our directory, it creates a hidden folder that we can access using, sorry, let me move this up again, ls-a, if you might remember from our last lesson, where -a stands for all. So it'll show everything in the folder, and that includes the secret.git folder. This is not a folder we ever have to go in and actually do anything to, but this is where Git will remember the changes we've made. So whenever we use all sorts of Git commands, which we'll get into right now, this is where all the magic is happening. It's just kind of sitting there in the corner of your directory. So far, so good? Did anyone get errors with the git init command? Awesome, okay. So now that we've initialized this, now let's actually make some files that we can track. So there's a helpful bash command that we didn't actually learn about last time called touch. And what touch will do is create an empty file with a given. Did we actually talk about this last time? I don't remember. Either way, touch will create an empty file with a given name. So we'll create a file called bio.txt, bio for biography, not biology, because we're talking about ourselves here. And then we'll make a second file, maybe for notes to ourselves, for instance, and we'll call it scratch.txt. So touch scratch.txt. Sorry, I'm a bit sick, bear with me. So running both these commands won't actually result in any output, but if we type in ls once again, we can see that these two files now exist. ls-a will show that our Git folder, our .git folder is also there. Now, when we are within a Git repo, there's a really handy command that, let me clear this up, that you can run as many times as you want, whenever you want, and I would recommend doing exactly that, and that is git status. And what git status will do is it won't actually do anything to the files in your repo. It won't change anything. It'll just spit out a nice summary of where Git is at with this folder right now. So if we were to break this down, right now it says on branch master. Git branches are not something we're going to go into in much detail today, but for now we can consider that as we're just in our the main version of our repo, because you can create alternate versions. But again, something we'll get into when we get to collaboration. No commits yet. So commit is a bit of a funky word. You probably think it, the English definition of it is very different from the Git definition of it, which is basically save points or checkpoints. What this is basically saying is we haven't saved any changes yet, but we'll fix that in due time. Then it'll say untracked files. And you'll notice there's two files down here, the two we've just made. They might be color-coded as red in your screen as well. I think it's platform dependent. But either way, this is Git saying, hey, I see these files in your repo, but I'm not tracking them yet. If you do stuff to them, I won't know what's going on. And this is something we might actually want for certain files, but we'll get into that. Then underneath it says nothing added to commit, which in Git lingo means nothing, no changes have been made to save, but these untracked files are present. And it's suggesting this one command called git add over and over. And so we'll do just that. In order to actually make Git track a file, we'll make it track with bio.txt for now. We would type in git add bio.txt. Right? Now this once again prints out nothing. But if we type in git status now, we get a much cleaner looking green thing over there. Now we've got this added thing where it says changes to be committed. There's a new file called bio.txt. Our scratch.txt file remains unchanged. Now this is super important to mention. Git does not just track everything in your directory, like outright. It's not just like, all right, there's a bunch of stuff in here. I'm going to track changes to every one of them. Because you can imagine, especially for larger project repos, if you've got like a 60 gig, I don't know, genomic data file, you don't want Git to track that necessarily. So git add allows for specificity in what we actually want to track, which is really important because sometimes there's stuff in a repo we do not want Git to even get near. So kind of the simplest way to avoid those is just to never git add them. But later, if we have time, we'll even talk about a method to make this whole dialog down here disappear. So it's not even suggesting that we might want to track scratch.txt, for instance. Yeah, OK. So I'm going to clear this up. So git status once again. Now that I've added bio.txt to this, it still doesn't save this change. I have yet to commit it. It still says changes to be committed. And this is us essentially delineating this as like a save point. So we would type in git commit, and here we're going to add a flag. We're not just going to write git commit. -m, and then in quotes, a message to ourselves. So I'm just going to write initial commit. You could write something like add bio.txt, something descriptive. And this spits out a bunch of stuff. It says one file has been changed. 0 insertions and deletions refers to the amount of lines that have been edited. So far, this is just an empty file. So that says 0 for both of them. It gives the commit a specific level code over there, which we'll get into in a second. Now, Git will not let you commit if you don't specify a message, which can be a bit annoying when you're just committing stuff over and over again, but it's basically forcing you to document your change. Like, it's not going to let you get away with just like making a change and then not writing anything, because it knows that 6 months down the line, you might be looking back at the change and going, what did I do here? So think of it as Git saving you from yourself in a way. All right. Now, the final thing is the commit. If we git status again, sorry, this is getting cut off. I keep forgetting my screen is a bit different from yours. Let me drag this up. There. All right. If we're to press git status again or type in git status again, now it has nothing. It's not saying anything about bio.txt. We've committed that. We haven't made any changes since. All it's pointing out is that we've got a different file in our directory that we have yet to track. So now let's actually make some changes to bio.txt. So use whatever text editor you'd like. I'm going to use Vim here, Vim bio.txt. You're welcome to use something like Nano as well. But if you're just going to stick to Vim like me, just type that in, Vim bio.txt. Press enter. If you get an error, then type in vi bio.txt. I think some computers might differentiate between that. If you're doing this in Vim, if you're doing this in Nano, feel free to type. If you're doing this in Vim, make sure to press I. And then let's write down first your name. So I'm going to write down my name, Ahmed. On a new line, your programming year. So I'm in the 2nd year of my PhD. Your favorite programming language. And I'm actually not too sure about this one. But as far as what I use the most, it's actually probably going to be Python. So I'll write that down. Much as I love R. And then on the 4th line, maybe a programming language you'd like to learn one day. So I know this is likely not going to happen, but I'd love to learn C++ one day. So once you've written those lines down, don't shake your head at me, James. What should I learn instead? So once you've made these changes, I mean, frankly, you could write anything in this file, but for consistency, let's do this. We have called this repo about me after all. If you're in Vim, hit escape. You'll notice the insert thing down there disappears, and then type in, literally as I say this, colon. You'll notice there's a colon down there, WQ, and then enter. Give everyone a second for that. Cool. me clear this up. So if we're to use git status once again, Git has once again picked up that we made changes to our file. Now we've got a bit of a toy example where we just wrote some stuff about ourselves, but you can imagine if this was a code file and you went in there and let's say added a new function of some sort, you might want to see what that function is. So in order to do that, before we've even committed it, if we've just made a change and Git remembers where the file was beforehand, which it does because we've committed, we can use this handy command known as git diff, and then type in the file's name. And what Git will do is it'll take the current status of the file, the previous status of the file, and actually return what's changed. So, excuse me, it's pointing out 4 lines in green, which means I've added these 4 lines. If I'd removed a few lines, it would have the lines I've removed in red. So basically, this shows you what changes have been made to this file relative to the last save point, which is handy for checking back at what you did. And later, if we're talking about collaborating with Git, in our later lesson, you could even see what someone else has done as well. But if you're happy with these changes, I'm happy with mine. We can get right to Git adding and then Git committing. So clear this up, and then we can type in git add bio.txt, and then git commit -m, and this time I'll added my bio as a description. And something descriptive. Make sure to have that description within quotes though. So if anyone's curious, the -m flag means message, I believe. So your commit message, if you leave that out, Git will actually open Vim for you. And it's like, buddy, type in a message. So that's why we just do that here all at once. And then finally, once we've done that, we can git status once again. Honestly, like the more you use Git, the more git status becomes almost a reflex. You do literally anything, you just type in git status without even thinking about it. But it's a nice way to make sure that your repo looks the way you expect it to. The things that you expect it to commit or are about to commit are what you want them to be. Finally, now we've made 2 commits so far. Eventually, as you work more within Git, you'll probably accumulate a lot more commits, and you might want to look back at those. So another handy command for that is git log. If you type that in, it'll print out kind of this history of all the commits you made with most recent first. So there's a lot of information going on over here. You should see something like this. It'll say commit, and then this massive string of letters and numbers. That's called a commit hash. And it's a unique identifier for that commit. And you can later use the commit hash to actually go back to a certain commit or refer to a certain commit for whatever reason. Apparently, the reason they picked this many digits was because it's apparently completely impossible to have 2 of the same commit ID when you've got this many. Maybe a bit of overkill here, though, considering we've got letters and numbers, but can't hurt to be safe. Down there, it should say author with your name, the name you've supplied at the beginning. So if you said something like Luke Skywalker, it'll say that over here. And the exact date, and then the commit. So there's also a bit of stuff over here about branches, but we can ignore that for now. As your log gets bigger, Git will actually just open this in less instead. So less, if you might remember from our bash lesson, is an example of a pager within a terminal. It's like, actually, we could use a pipe to see what it's like right now. So we could type in git log pipe and then less. I'm just doing this for demonstrative purposes. As your commits grow, it'll open this automatically in less. And so less will open this as if it were like almost, you could think of it as like a file. And you could scroll around in this, but we don't have enough lines.
And just to point out that if you were collaborating on this with somebody else, you wouldn't only see your commits here. You would also see those that other people have made. So like with their name and the date that they made those changes, because you're all working off the same repo. Exactly. Yeah. Which is helpful too if you're working with multiple people and you come back to your repo or that repo after a couple of days and a bunch of changes have happened, you can see each individual change because they're also forced to document what's going on. So that's why this is really robust when it comes to collaboration versus something like Google Docs, which is still super useful, but like each individual change isn't tracked and documented per se. And that's fine for documents, but for really large extensive code bases, you want every line of code to be accounted for, especially if something ends up breaking, important functions and such. So if you're in less, you can press Q to get back out. And one final thing I want to mention is that Git log actually has a host of features that can kind of prettify this output. So I'm not an expert at this. I'm old school and just use what I see over here. But James has found a bunch of cool features. So I'm going to clear this up. Typing in clear. If you type in this exact combination of flags, so git log -- one line -- all -- decorate
-- graph. It's a lot of flags, but when you press enter, you get this much prettier output. It gives you the first 7 or so letters of the commit hash, which actually, as it turns out, if you use the commit hash in any commands later on, the first 7 or 8 letters are actually sufficient, usually because within your repo, those are unique, alongside the actual commit messages. So especially as your git log gets huge, this is actually really handy. Of course, you might not want to type this out every time. So does anyone remember a thing we learned about at our bash thing 2 weeks ago to, let's say, save a command to a shortcut? It's okay if you don't. Yes, well, not quite the path, but in your bash RC or bash profile. So within your home directory, you've got that bash profile file, or bash RC on Linux machines, I believe. And you could use aliases. So alias, maybe something like glog equals, and then you could write out that whole command. I'm not going to run this here because I'm just writing this up for demonstrative purposes. But it's worth remembering that whenever you have something long like this, even if it's a git command, like it's not like a base bash command per se, you could still make an alias out of that and save yourself a lot of typing down the line. Cool. Okay, so any questions on that so far? Was there any command that was unclear? So we went through a couple of pretty much the core command line git commands, I would say. So git add, git commit, well, of course, backing up git init to actually start our git repo. Git log to see the history of commits, and then git diff to see how an individual file has changed, and perhaps most importantly, git status to see where our repo is. There's a few more commands still, but those are pretty much sufficient if you're at least running or keeping a bit of like a documented code base for yourself. And these are commands any Git user will be using primarily pretty much every day. But what we're going to do now is actually take this repo and what's called push it to GitHub. So we've got this repo, we've got these changes that we've stored and saved. And what we're going to do is basically create a copy of this over on GitHub, where not only is it publicly available, but you'll get access to a host of useful collaborative options. So now we're going to put the terminal away for a second, head over to our browser and open up GitHub. So that's just www.github.com. I'll stop for a second if people need to log in. Is there anyone who still has yet to make an account? Okay, well, it shouldn't take long, even if you need to do that. But yeah, so just log into GitHub on your browser of choice. All good? Okay. So does anyone not see something like this? Maybe not as crowded, but like this sort of page over here. Okay. So on the top right, all we're going to concern ourselves with is this plus icon. And if you click on the plus, there's this option called New Repository. So we'll be clicking on that on the top right. Oh, they have an import setting too, but we'll just do it the old school way. Click on New Repository, and you'll be directed to a page that looks something like this. It'll ask who the owner is, which should be you, and then what you want to call the repository. So for consistency's sake, we'll also call this About Me, just so it's the same as our desktop file. You can add a description if you want, but as it says, it's optional. You can also choose to make it public or private. So this is a cool new setting, actually, just as a few weeks ago. Before you had to pay for private repos, but now they're free. So
For everybody?
yeah, the more you know. I'm just going to leave my public for now. Generally, as you have your own code bases, even if you're not collaborating, even if you're just keeping code that you have for a project, it's better to keep things public because, at least in the tech sector, it's super common that if you're applying for a job, you not only have like your CV and the like, but you also show kind of your portfolio of GitHub repos, because then anyone can go in and see what your code looks like and how meticulously it's documented and such. So it's good generally to have a public code base, not only for that, but also because other researchers are doing the same thing as you. So I think this recently happened to Rose, where she was looking for something related to accessing stuff from the GeneBank database and found a really cool script just sitting on someone's GitHub that did the exact task she needed. So stuff like this, it's super useful for that reason, because someone might need your script and then they might use that and then cite you. So this is another cool thing about GitHub, and why like most computational biologists often upload their scripts and such to GitHub for other people to use. So you can keep it public or private, your choice. The most important thing over here is to leave this unchecked, this initialize this repository with a README. Leave that unchecked. The reason is, if you check that, that's kind of insinuating, although it might not be immediately obvious, that you're creating a new repository, completely fresh. But what we're doing is importing an existing one. So we're not going to do that. What this would do is create a new empty repo with a file called readme.md, and then importing a repo would be a bit more troublesome. So leave that unchecked. And once you're done, just click Create Repository. And so we've created this. We've created our repository on GitHub pretty much. But you'll notice there's no files or anything here, just a bunch of command line instructions. So Git is actually pretty handy about telling you exactly what you need to run in the terminal in order to get your existing repo onto GitHub. But we'll just do it directly in the command line because I'm here and I can just say those commands one at a time. So first, let's remind ourselves that we're in the directory that we want to be in. So we'll type in pwd, print working directory. And we are, so that's great. Now we're going to talk about a new command briefly, and this is more relevant to GitHub than just working with files locally in your command line. We'll type in git remote, and then -v at the end. So this is basically saying print out what remotes I have, and what that is will become apparent in a second. Right now we don't have any. Remotes are, you can think of them as kind of links to outside kind of hosts of Git repositories. So GitHub being probably one of the most common ones, but there's other websites like GitLab, there's Mercurial, I believe. Some services, some writing services such as Overleaf also act as Git repos in a sense. So this is where all those would be listed, but we don't have any right now. So we're going to add one. So I'm going to clear this up. Go back to Git, or GitHub rather. And there's a link up top over here. There should be an HTTPS option. I've got a couple extra security settings, so I'm going to have to use the SSH option, but you're fine with the HTTPS. Just copy this link over here. Right to your clipboard, Control-C, Command-C, whatever your platform requires, and type in git remote add origin, and then paste the link. It's a pretty multifaceted command. There's a lot going on here. But I'm going to hit enter here. It's not going to print out anything. Did everyone get through that okay? Now, if you type in git remote -v once again, now it points out that we have this remote set up. Again, your link might look a little different than mine, but the idea is that we have this outside Git repo that we've called origin. So that's kind of the standard name for it. You can call it whatever you'd like, but convention is to call it origin. So git remote has a bunch of commands within it. So there's git remote add, git remote remove, ostensibly, or whatever the equivalent is. But we've added this new remote, we've called it origin, and there's the link. And Git can figure the rest out. Now that we've created this link between our local repo and the one on GitHub, the final thing we have to do is actually push what we have locally to GitHub. So we're going to be typing in git push -u, so -u stands for upstream, origin master. Uh-oh. All right. That shouldn't happen for you. It's happening for me because I always forget my security settings. Give me a second over here. Did anyone else get this error?
You gotta log in. Yeah, login prompt.
Oh, if you get a login prompt, just log in with your Git credentials. Yeah, I think I set this up ages ago, and I might have set it up to bypass the login thing every time. So while you guys are logging in, I'm just going to get the other. Don't mind me over here. Git remote H. It is git remote remove. Okay, git remote remove origin. You don't have to do this. I'm just clearing mine out. Git remote add origin link. Git remote V. Okay. Is everyone good now? Did the login work just fine? Great. So I'm going to do the git push once again. -u origin master. It should work now. Oh, let's forget whether to use HTTPS or SSH. But yeah, you should see something that looks exactly like this. If we're actually squint at this for a second here, it's pointing out how many kind of objects it sent over. So that includes the .git directory, how fast it did it. The master bit at the end of our command, once again, refers to the branch. So by default, again, the default branch is called master. Branches are a way to hold like parallel versions of the same folder, but it is still useful when you're working on your own, but I would argue way more useful in the context of collaboration. So again, we'll be covering that when we get to the collaboration lesson. But that's all master means, really. And so now if we go to GitHub and just refresh this, we should see something very different. Is this what you guys see? No? Sweet. Okay. And so this is our bio file. You'll notice it says added my bio, which is exactly the commit message I wrote earlier. And on top of that, if you look at this kind of bar up here, it says there's 2 commits, the commits we've made essentially. Excuse me. 1 contributor and all, and so on. Now there's added bells and whistles we haven't really talked about, so such as releases, projects, pull requests. These are more GitHub specific things, and they're added features to. So for instance, some people host entire kind of software packages on GitHub, and so they can delineate certain points in time within the commit history as a given release. So one can imagine dplyr 1.0, which is hosted on GitHub. They can release that certain commit as dplyr 1.0, and then anyone can go back to that. So that's not something you have to know. I'm just pointing out that this is one of many, like these are some of the features that GitHub has added on top of kind of standard Git. So if we'd like, we can actually click on bio.txt, peek inside it, and kind of it looks exactly the way we left it in our command line. In fact, we can even edit it from over here. All right. So let's actually just do just that. You can edit files from GitHub. So let's click on edit this file. Sorry, another thing I meant to point out. I don't think I have to go back for this, but you'll notice only bio.txt was there. Scratch.txt was not. And it's important to mention that in our local directory, that still exists. That file wasn't deleted. It's just that Git wasn't tracking it. So when we pushed it to GitHub, Git was like, I'm not touching that file. The user doesn't want me to. So although it exists in our local directory, although it's not going to be wiped or even touched by Git, it's not on our GitHub version of this folder, because when we pushed it, it was just bio.txt that had commits happening. So anyhow, on the 5th line of your file, let's add, I don't know, what did I write here? List your favorite color. Mine is blue. My desktop background didn't give it away. But just add your favorite color or whatever else. Scroll to the bottom of this, or actually, let's actually look at this up here. Sorry, scroll back up. If you click on preview changes, it almost shows you like, well, not almost, it literally shows you what the Git diff will look like in this nice little format. So it's just telling me that I've added this one line. So I'm going to go back to edit, scroll all the way to the bottom, and you'll notice it prompts us to commit our changes. So what we're about to do is effectively the same thing as when we typed in git add and then git commit m. We're just doing this from the GitHub side now. It's the same operation. So over here, we can add a description as we've been doing in the command line. I'll write added my favorite color. The cool thing here, and this is more GitHub specific, you can actually add an extended description. I don't believe this shows in the commit history, but if someone sees it on GitHub, then they can click on it and see the full description as well, which is useful for adding a bunch of things. So set it to commit directly to the master branch. The second option is more for collaborative purposes. So select the first option, things automatically selected, and then click commit changes. All right, and now we have it. So over here, we've got the commit we just made. It's listed up there as the most recent commit. It says we made that just now. That over here is the commit hash that I mentioned. And here's my file. So I can go back to about me, and I can see over here that there's now been 3 commits. You can even click on the commit history over here. So this is a nice looking Git log equivalent. So I'm hoping you guys can see kind of how this translates, the command line version versus the GitHub version. GitHub is just a nice like front-end interface for what we were doing in the command line anyways. But now we've made a commit on GitHub itself. Does that mean that our file locally is automatically updated? Well, no. That would be nice in some instances, but Git, if we type in cat locally, back at the terminal, if we type in cat bio.txt, so cat being concatenate, which prints out the contents of that file, we'll notice that the local version of my file still doesn't know my favorite color, which is tragic. So the reason for that is although these are 2 separate repos in a way, they're linked to one another, but changes in one will not automatically show up in the other. We have to explicitly pull that. And this is once again, in a way, Git saving you from yourself or from erroneous changes maybe someone else has made, because you're maintaining this kind of this separate folder. And if you're sure that you want these changes pulled to your local version, then we can do just that. So in our case, I know that my favorite color is fine, and I would want that in my local directory. So now we're going to use another command known as git pull. So git pull is a command that's specifically for use with remotes like GitHub. And excuse me. If you had more than one remote, you'd have to specify what you're pulling from, but that's kind of rarely the case, I would say. So generally git pull will suffice. It'll take the changes we had on GitHub, and you'll notice it says over here, bio.txt, 1 line added. 1 file has been changed and 1 insertion has been made. If I type in cat bio.txt, now I see that this file has been updated. So although this isn't like the most kind of realistic use case in the world that you'd make an edit on GitHub and then go back and then make an edit locally and then go back, what you'll often find yourself doing this operation for is if someone else has made changes to your repo. So if you're, let's say, working on a script with someone else and they say, hey, I've added a bunch of code over here, before you start working, you would want to pull their changes down to your local copy. So you would do just that, and then you can continue working on it.
Can you do that from GitHub?
Do like pull from GitHub? No, that's a good question. Yeah, so your local repository, although they're linked to GitHub, I don't believe there's any way to like control what's going on in your local repo from GitHub. You have to go to your local repo and run this command in bash. I don't think there's, do you know, James? Yeah. Yeah.
You can't push from the GitHub.
You can't, no, you can't push.
You can't like push from GitHub to your local repo.
You have to, so pushing is always to the remote and pulling is always back to the local thing. Those kind of directionalities never really switch. And conversely, what we'll do just now, right now is, if we made more changes locally, we'd have to push them to GitHub. So let's make one more change to bio.txt. So I'll clear this, open Vim once again. So Vim bio.txt, or nano if you prefer. And in Vim, you can press, I won't go into Vim shortcuts, just press I and use your arrow keys to make it to the bottom. So Vim has handy shortcuts to avoid doing that. And on the final line, let's add the brand of computer that you have. So I've got a MacBook, for instance. It's a nice summary of who I am. Once you're done with that, once again, if you're in Vim, press escape, and then type in :WQ. It'll show up on the bottom left again. Enter, and your changes have been saved. Check those once again with cat bio.txt. But as you might expect, and we can check this just to be on the safe side, if we go back to GitHub, refresh, the most recent commit on GitHub is still added my favorite color. It doesn't even know that this commit has been made locally. Although it is pretty smart about that on the collaborative side of things. But right now it has no idea. So in order to push this change we have to GitHub, we would have to use kind of the same push command once again. So we would first go through the motions of adding. So let's just git status, as we should reflectively be doing. Bio.txt is modified, but it's in red. It has not been staged for commit. So staged is kind of a fancy way of saying, like, have we run git add on it, basically. When you do that, it's considered a staged file. So we would type in git add bio.txt. Once again, commit. So git commit -m, and then type in, what did I do again? Oh yeah, added my computer. Computer brand. It'll print out what it does, that we added a line, and then finally git push origin master. This will take a second. It'll figure out how many objects we have, send it over to GitHub. Did everyone get that when they ran the git push command? Finally, if we go back to GitHub, boom, there it is. Fourth commit has been kind of registered over here. This has been updated with the new commit. And if we click on bio.txt, my computer brand is down there as well. And now we're all synced up on GitHub. And that, if, in all honesty, if you were to, leave this lesson right now and be like, all right, time to get a code base going, that is pretty much all you would need to know to have a code base running on your computer, or building on your computer rather, and on GitHub as well. You would make changes to the code base you have in your Git repo. You would make sure to commit them as you go. And then once you've set up your remote, you could push them to GitHub. I found in my experience when I've done that, I haven't often been editing on GitHub and pulling, just because I prefer to work locally and not the other way around. But you also know how to pull from a GitHub repo, which becomes especially useful in the context of collaboration when someone else is also working in your repo, and you want to make sure that you have the most up-to-date version of I guess the code base. I keep saying code base again, but you can write manuscripts in here. You can write, you can keep data in here. You could even put in, it won't be great for version controlling, but you can upload plots and stuff to GitHub. And in fact, I've noticed that it's becoming a common trend, especially in fields that are in papers that even involve some scripting, that authors at the end will say all scripts used in this work are available on this GitHub repo. And then over there, you could pull up their GitHub repo, see all the scripts they used, see files describing how to use those scripts, and even have plots as well. Kind of the gold standard of that, something I saw on Twitter, which I thought was super cool. Someone was like, our paper is now out. Go to this GitHub repo, download it, and then run this one script to recreate the paper from the repo, which is pretty bonkers to me. Like all the code is there, all the data is there, and it just like remakes the paper for you. So all stuff you can do in Git. Beyond that, it has other uses. So like I said, the website that James and I have up for this coders thing is all hosted on GitHub and is generated from GitHub. So although these GitHub repos are based on the same kind of core commands we've been looking at, they have a ton of added functionality on top of that. So to review, we covered some really important fundamentals, some really important commands. So first we told Git who we were, git config, but that's likely not something we'll have to do again. I think this was my first time running those commands again in like 4 years. But we learned how to add stuff. We learned how to commit stuff. And we learned that Git status is a great way of checking where our repo is at a given point in time, while Git log is a way of looking back. And now you'll notice, actually, this should happen to you as well, I think, if you should have enough commands that it opens the less automatically. It didn't just print it out to my screen. So I'm going to press Q now and get back out. And then finally, there's certain commands we use specifically with remotes. So git remote being an obvious one, with git remote v pointing out what remotes we have. And on top of that, push and pull. So to be very clear, because it's easy to forget, pushing is always to GitHub and pulling is always from GitHub. So, and I kind of like it that way because it's consistent in the sense that if I'm working my local repo, push and pull will always mean the same thing. All right, so that wraps up the main material. I've got a bit of extra material on how to revert commits if it ever comes to that, and also how to make Git ignore files. So we could take a breather here for a second. I know I need a breather to drink some tea, but are there any questions so far? Because there's a lot of material, and don't feel bad if Git takes you a while to wrap your head around. It took me like, I would say just under a year of constantly working with Git to be like comfortable with it and not have to look up every command every 5 minutes. Like that's fine, it happens. It's kind of like memed about to death. So it takes time, but with practice, it becomes almost muscle memory. All right, any questions? Anything you've heard about that people do in GitHub that you'd like me to maybe briefly talk about / show you? Okay.
Is there a way of like following the coders GitHub so we can have all of that stuff on our own page?
Yeah, that is a good question. That's the watch feature. So GitHub has all these social features. You can follow people, you can like their repos or star them. So you can fork them, but that's more for collaboration. It has nothing to do with utensils or innuendos. And so yeah, if you'd like to go to the coders repo, let me just show you where that is right now. So you can search for this. It's right here for me actually, but you would type in utm-coders/study G group.
You can see all of mine on.
Yeah, so it'll show you that there's, wait, what did I mess up over here? Oh, it's looking for it in the repo. Sorry, my bad. You're gonna have to go back outside of the repo because right now it's gonna search within the repo. So click on the little GitHub cat icon over there. And then I believe from here you can type in utm-coders/study group. I think it might autocomplete even. This is big enough for people to see actually. I know the browser's got a bit smaller text, but.
Yeah.
Okay, let me type that in. utm-coders/study group. So, oh, odd. Okay, well, I guess another way to do that would be
Just do UTM coders.
UTM coders, exactly. So type in UTM coders, it should find, there's a bunch of stuff over here, but if you look over to the left and click on users, it takes you to, so this isn't technically a user, it's what's called a GitHub organization, but that doesn't particularly matter. If you click on that, you can scroll down to study group. And from study group, you can click on watch. And I've noticed two people, well, one other person already has. Let's see who's watching. Oh, that's Brian. Okay, that's someone who's he's affiliated with the coders group downtown. So So this actually, something I want to point out here, you'll notice it says it's forked from U of T Coders study group. So a fork is a copy of a repo. And we'll talk a lot about using forks when we talk about collaboration, because basically the idea of a fork is you make a copy of a repo, you make all your changes in it, and then you submit a pull request where you're basically telling the owners of the original repo, hey, if my changes look good, pull my changes to your original repo. So we forked it from the downtown group. So for those who don't know, there's a downtown group called U of T Coders who have been doing this for way longer than we have. And we actually adapt a lot of our materials and website from them with their permission, of course. But so we forked their website and use that to build our own. So if you'd like, since James and I have made these lessons via pull requests, you could click on pull requests over here, click on closed, and you can actually see the inner workings of how this Git lesson was made, for instance. So if you click on add Git lesson, here's a description from me. Here's a bunch of commits I put in making this lesson. Here's some edits from James. So these are all features we'll talk about when we get to collaboration, but it's like really built to facilitate that. So once James points out these, I can incorporate these edits with a new commit, and then James can approve them and merge them. So this is all stuff you can do from GitHub. I don't believe command line Git has features for this. But again, something we'll explore more when we collaborate. So yeah, we've got more watchers. If you really like the repo, you can star it. It doesn't actually do anything except make us feel good. And I believe you can set statuses on GitHub now too. It's like happy or busy because it's 2007 and we're back to MSN Messenger. All right, so one other thing I wanted to mention beyond the two kind of appendices we've got here is cloning. You might find in your own research, you might find if you want to use someone's software that's on GitHub, they'll often say, oh, just clone the repo, aka download the repo. So let's actually go back to our about me repo. No, that actually won't make sense because we can't. Let's clone the study group repo. Does everyone have that open, or did some people it's not opened up? I'm not, okay, cool. So you'll notice there's this big green button over here that says clone or download. Click on that. There's a link over here and a download zip option, which you can also use, but we'll actually copy this link over. So I'm going to copy that. And then I'm going to CD back out to my desktop because I don't want to clone this into a different Git repo. I think that would be like repoception. It'd be horrible. So I'm going to use cd ... which takes you back one directory. So now I'm back in my desktop. You can type in pwd to make sure you are where you want to be. And then type in, and you can do this anywhere. You don't have to run this command in a Git repo. You can type in git clone and then paste the link. And there'll be like a whole command line dialog. It'll take a bit because it's downloading essentially all the assets in the entire website. And once that's done, you can type in ls and see, oh boy, where'd it go? Study group, there it is. So I'm going to cd into that. I'll clear this up. Study group, ls, and that's the entire repo. You can go in and see the lessons. In fact, you can type in git log and scroll through all the commits. So the advantage of using git clone instead of just downloading the zip is you can actually use git commands on this. It's useful if you clone someone else's repo and also want to collaborate with them. But often I find that if there's software someone's written that I want to use and it's hosted on GitHub, you can just clone it and then get to using it from within the folder. So that's a handy thing to know because it's something you might encounter as you work more in the computational biology space. Cool. All right. So,
And if you wanted to leave the workshop on anything at any point, you would need this repository cloned on your computer because that's how you would that's where you would write the lesson material and then push it to GitHub so that Ahmed and I could look at it and make it available on the website and do all sort of that stuff on the back end.
And if when you do that, and if it's before the collaborating with GitHub lesson, we would obviously help you through that. Not so subtle plug, but okay. So the final two things I wanted to cover, these were kind of like if we have time sort of things, and we do have 15 minutes, and they won't take particularly long. So I'm going to cd back into the about me directory. So cd ... and then cd about me. Type in ls or git status just to get like a bit of a refresher of where we're at. let's say you made this horrible commit where, I don't know, you pasted in like the third Harry Potter book instead of the function you wanted to do, and you just committed that for whatever reason. It happens. So git feature is a handy command where you can essentially undo the last commit. And a better way of thinking about this is, so if I type in git log, so this is my latest commit up here, added to my computer brand. Undoing this commit is analogous to basically bringing the repo back to the status it was when this commit happened. You can think of it like a time machine. Just you go back to that exact point in time, and then any memory of anything that happened after that is gone. So the command for that is git reset. And I'm not super attached to my computer brand, so I'm gonna remove that. Now git reset has a couple of, we could call them flavors, I suppose. If you want, you can type in git reset /-h, and it'll print out the different ways to do them. So mixed, soft, hard, and so on. These are all different ways of resetting. And they have some jargon in there that we won't worry about for now. What we're going to do is called a hard reset, which is kind of an undo in the classical sense, as if this latest commit never happened. It'll just go back to the previous one, no memory of that commit, that's it. So I'm going to clear this out and type in git reset --hard. And then we're going to get introduced to a new term, which is head in all caps. Head is what Git calls the current state of the repo. So when we just type in head, it's current, it's referring to what the repo is right now. But you can specify kind of commits ago relative to head with the tilde. So head tilde1 means one commit ago relative to head. If we're to type in tilde2, that would be 2 commits ago relative to head. But we'll just do 1, which would effectively undo the commit we just did. Type that in, it says head is now at previous commit hash, added my favorite color. So when the commit I made that had that message. If you cat bio.txt, the laptop thing is gone. If you look at git log, that whole commit is gone. It's like it never happened. So there are other flavors of git reset. I believe git reset soft will pull you back, but like not entirely delete the commit. So if you want to do a more experimental sort of thing, but those are a bit more complicated to explain, and I also don't use them very much. So, question?
So you didn't push this to GitHub yet.
I have not pushed what I did to GitHub.
It still has the computer brand. So if you fucked up and you didn't actually need to go back, like so you went back 2 and you only went to go back 1.
Yes.
Could you pull from GitHub?
Absolutely. That's a great point. We could do that right now if you'd like. So I'll just have to git pull. And we're back. Kind of the advantage of having one thing in 2 places. There's a different way of reverting commits known as git revert. I tend to use git reset more, and I believe, don't quote me on this. I would honestly have to look this up because that's how Git is. You just look things up before you do them. Git revert will undo the previous thing, but save that change as a new commit in a way. So the new commit will be revert this last commit, and I'll just undo that. It's kind of the safer way, but often if I find I have to reset something, it's not something that I want to keep history of anyways. But something to keep in mind if that ever happens. But yeah, git pull is exactly one way to get something back. Alternatively, if you delete it on GitHub by accident, git push would be one way to push it back from your local repo. So, but yeah, git reset hard will like those changes are lost for good. There's apparently like a kind of niche command called git reflog, which for a few days will keep memory of that commit that you can use to get it back. But I've never had to do that, and for all intents and purposes, you can pretty much assume that that commit is gone, like gone. Of course, sometimes we might want to go back using this whole like time capsule analogy to an earlier point in time without actually undoing stuff. And this is something you actually can do with Git. You can kind of like float into an earlier point in time and see what things were like back then. And to do that, this would use a command known as git checkout. So I'm going to clear this, and then git, and then checkout is one word. Git checkout is actually a super useful command that has many uses, especially on the collaborative side of things as far as branches go. But right now, we'll just use it in order to switch to a different hash. So tell you what, let's actually get a hash first. So let's press Control-C to cancel this command. I'm going to type in git log, and then head over to commit hash. So down here, the added my bio commit. Let's say I wanted to see what the repo looked like back then. What you could do is highlight this whole thing. You don't actually have to highlight the whole thing. About like the first 9 or 10 letters should be fine, which is why GitHub and like a shorter version of GitLog don't show the whole thing. Highlight that and copy it to your clipboard. Control-C, Command-C, whichever it is on your computer. Get back out with Q. And then if you were to type in git checkout and then just that hash, whole bunch of stuff just like spits out. And what Git is telling us is we are in detached head state. Yeah, which is what we'd expect. And what that means is, remember when I said that head is the current state of the repo? What we've basically done is like kind of floated head over to that previous state of the repo, and we're just like squinting at it pretty much. But that doesn't mean that the previous head, like the actual most recent state of the repo, has changed. That's what's called detached head. So we can look around, we can make experimental changes, which I would not advise doing without branches. But if I type in ls now, or sorry, rather cat bio.txt, I can see that earlier version of this file. I can type in git status and even see what the status was at the time. It says head detached, we're currently at this commit, scratch.txt is untracked, and so on. So this is useful in a time machine sense. Something I've done in the past has been like, oh, I'm not using the script after all. I'm just going to delete it because I don't need it in my repo anymore. And of course, Git will make you commit the fact that you're deleting this file. And then a month later, you can be like, whoa, I totally need that. And you can use detached head state to go back, just, I don't know, copy it to your clipboard even, get back out, and then basically like recover that script. I'm sure there's fancier Git-based ways to recover files, but that's worked for me. If you want to get back out of detached head state, we would type in git checkout master. Remember that master is the name of our current branch, and this basically means bring it back. Previous head position was this commit, switch to branch master. We're now up to date with the GitHub version. So that is another huge advantage of keeping track of your changes as you go along. Any questions about that? Great. And now one last thing I want to mention is known as the gitignore file. And this is something you'll see a lot and probably want to use, especially if you use Git in your own projects. So let's type in git status once again. And we've got this scratch file called scratch.txt. But imagine we have no intent of ever committing this. Like we don't want anyone else to see it. We're frankly kind of annoyed that every time we git status, Git is still like, are you sure you don't want to add this? It's like, yes, I'm sure. I don't want to see this. I know that it's untracked and I want to keep it that way. This can get really annoying, especially if you have, let's say, a bunch of data files in your folder that you never intend to track, but will keep popping up anyways. What Git allows is that you can make a file called gitignore. So I'm going to clear this. And this is like any other flat file. So we can use vim to open this up. So I'm going to type in vim.gitignore. The dot is super important here. So basically, we're creating an empty file right now called .gitignore. This is an empty flat text file. Question?
What's the difference between opening a file that doesn't exist already and using touch?
Oh yeah, that's a good point. If you use something like Vim with a new file name, it does all that in one step. So it creates this new file. Although, hold that thought, but creates this new file, then you can edit it, and then when you save it, it'll save your changes and the fact this new file exists. Alternatively, though, if you do this Vim gitignore thing, but you don't save your changes, then that file will never be made. Touch will create an empty file with that name. So it's useful to make like a little placeholder sometimes. The only reason we did touch in the beginning was because I wanted to have those, the creation of the file and the addition of stuff to the file as separate commits, but you could do it all in one step. So I'm going to create this file, yeah, gitignore. And in gitignore, there's no bells and whistles to it. You just write the names of any files or any folders you want Git to like not even look at. So if you're in Vim, you would type in I, and type up scratch.txt. If you had another file name, you just put it on a new line. So we just have scratch.txt. So once I type that, I can hit escape, :WQ. It won't print out anything. We've just made a text file.
And for those who were here last week, you can use wildcards and regular expressions and stuff in your .gitignore if you want to like ignore everything that ends with .txt.
Yeah.
Like asterisk.txt, it'll just ignore all of those.
Yeah, or everything within a folder even. So it could be like folder name /star.fasta, and it'll ignore all the FASTA files in that directory, which is really useful. But now if we type in git status, well, now it's complaining about gitignore, which is pretty meta. Now you can commit gitignore, or I believe you can add gitignore to gitignore, right?
That's why, like gitignore inception.
But what we'll do is commit gitignore. So I will go git add .gitignore, as we've done before, and then git commit -m add gitignore file. And now, if we type in git status, it's gone. It's not bugging us about scratch.txt anymore. Another thing, though, is that we've committed this, but it's not on our GitHub. And you'll notice it even says your branch is ahead of origin, so being our GitHub repo, by 1 commit. So to wrap this all up with a nice little bow, git push origin master. Now our gitignore file is also on GitHub. So now if we type in git status, it'll never bug us about scratch.txt again. Something to clarify, though, is if you have a file that you were already tracking and you add that to gitignore, it's not going to suddenly ignore it. It'll be a bit confused, I'm sure, but it's not going to untrack it anymore. There's a different command for that, which I believe was, no, I don't remember it. It's git rm --cached, which will not delete the file because git rm would actually delete the file. It won't delete the file, it'll just remove git's tracking. But this is the sort of command that I would not remember off the top of my head and just Google every time. Remember that you can Google anything. Just like, how do I undo a commit in Git? And there'll be like a huge 10-step tutorial with like shell commands. Or how do I stop Git from tracking a file? And that's an easy way to pull this sort of thing up. So yeah, that's gitignore files.
And if you do remove a file, remember like last week we talked about like when you remove a file at the command line, it doesn't go to your trash, it gets vaporized. If you do remove a file and that file is in a Git repo, you can get it back using the techniques that Ahmed showed earlier, like reverting to commits and stuff where it existed.
Yeah, or even using detached head state to just pull it back out.
So Git is always just trying to save.
Yeah. And kind of the advantage of it is if you get in the habit of documenting your changes, you can be a bit more like loosen up a little bit as far as like removing files, as far as like making big changes, because you know that everything's essentially backed up in a way. So that's why back then I was like, I can delete the script, I don't need it. And then when I did need it, it was pretty much trivial to get it back. So you can keep your repo or your folder looking the way you expect it to, but you can also like, although typing up, documenting all your changes feels a bit rigid, in a way it allows you to like take it easier in a lot of other ways because you have that peace of mind. And the other cool thing is you won't have like something, let's say like manuscript -1, manuscript -2, manuscript -final, manuscript -supervisor edits -final, because if you were to have that as a Git file and then you were adding any changes that were coming in and tracking them, you just have one manuscript file, and then that entire history of changes can be accessible via the commit history. So it also just keeps things neater in addition to all that. So that's going to wrap up me blabbing about Git. If you guys have any questions, if there are any bugs you encountered that you wanted to look at the end of class, we can totally do that. But I hope this was useful. I would argue Git is like one of the most useful, if not the most useful, like non-programming language like tools you could have in your tool belt, I suppose, if you're doing anything computation related in research or otherwise. And yeah, I keep going on about that collaborative lesson, but we're going to make that happen, and hopefully you guys will be more convinced, if you aren't already, of just how useful Git is. So yeah, that's about it. Thanks
for
for coming.
Useful way for us to collaborate on code.
Yes.
Copying code.
Yes. For context, James and I, along with 2 other people downtown, we made an entire 30-year course in GitHub last year, and it was so clean because you all know how the Git flow works, and there was no issue of like, who made that change? Where did this file come from? Everything was documented, everything was clean, everything was approved by everyone else. We worked on a manuscript about that course over December, and it was honestly a joy to work on because Git just facilitates it so much. But I'm going to stop blabbing now. So thanks everyone for coming. Like I said, we'll send out the survey about other lesson topics. And again, if you have any other questions, I'll be around. Cool. Thanks for coming.